In this video, I'm going to teach you how to find the equation of the tangent line for a given curve. So in this question here, we're asked to find the equation of the tangent to the graph y equals x cubed plus x squared take 4x plus 1. And we're asked to find it at the point minus 2, 5. So if I were to take a rough guess as to where minus 2, 5 would be, in this graph it would be roughly here. And this graph is not to scale, but I have drawn it in such a way where minus 2, 5 is over there. So I want to find two things whenever I want to find the equation of the tangent. A line will always look like this. It will always look in the form of y equals mx plus c, and this is slope-intercept form. The first thing I need to find is the derivative or the gradient at this point of the graph, because that's what's going to allow me to determine whether it's going to be positively increasing and negatively decreasing, or by how much it's increasing and by how much it's decreasing. And so I'm going to just differentiate this curve here. And the derivative of that curve, we would simply use the power rule, which is you bring the power to the front and then minus 1 from the power. And so this would be my derivative. Next, I would need to find what the derivative or the gradient is at this specific point here. So when x equals minus 2, I want to know what is my gradient. And so the way I'm going to do that is just substitute in minus 2. And if I do that, I have 3 times 4 plus 2 times minus 2 take 4, and this will just give me 4. Next, what I need to do is I need to write it in slope-intercept form. Y equals to 4x plus c, because I just worked out the gradient is 4 at this point. So all I need to do is work out the value of c. And the way you do it in these tangent derivative problems is you just substitute in the points that you're given. So I know that y equals to 5 when x equals to minus 2. And so now I can rearrange for c. So 5 equals to minus 8 plus c. And that means that c is equal to 13. So therefore the gradient line or the derivative of my tangent is 4, and the equation of my tangent is y equals to 4x plus 13. You can pause the video and have a look on Desmos whether this is correct, but this is how you find the equation of a tangent to a specific curve. Now we're going to have a look at this example here. We can see that I haven't given you a graph and I haven't given you any coordinates, so we have to do everything by hand. So the first step we always do is we want to work out the derivative or the gradient of the line at the point where we want to work out the tangent. So I'm just going to differentiate the curve that I'm given. And in order to differentiate sine, all you have to do is you have to turn it into cos. So 2 cosine of x plus pi on 2. And then you have to times by the derivative of the inside function here. And we know that inside function is just 1. The derivative of the inside function is 1, so I'm not going to bother timesing by 1. This is my derivative. But we're not interested in just the derivative at all points. We're interested in the derivative specifically at x equals to 3 pi on 4. So we're going to work that out now. We substitute in 3 pi on 4, and we would get this value here. And from your trig values, you know that 5 pi on 4 is in the third quadrant, and you know that in the third quadrant cosine is negative, so you know the value here is going to be negative root 2 over 2. And so your answer is minus the square root of 2. That is the gradient at x equals to 3 pi on 4. So now what we can say is, because we have the gradient now, we can work out the value of m, or I should say we already have the value of m. We know that because y equals to mx plus c, we know that m has to be minus square root 2 over 2. So all we have left is to work out the value of c. However, we don't have a point that we're given. So how are we supposed to work out what c is? Well, because we're given the x value, we can manually work out the y value by just substituting it back into this equation here. So I'm going to work out what the y value is when x equals to 3 pound 4 for the original curve. And if I substitute it in, I know from before we'll have 2 sine of 5 pound 4, and this is just simply root 2. Next, because now I have a coordinate, I know that I have the coordinates 3 pi on 4, comma the square root of 2. I can substitute this point back into the tangent line, the unfinished tangent line. And so what I'm going to do is, I'll scroll down a bit. This is our tangent line. I'm just going to substitute in the coordinates that I have and rearrange for c. So I can say when y equals to square root of 2 and x equals to 3 pound 4, this statement has to be true. So now if I want to rearrange, I can I can expand out this bracket. So I can get minus 3 root 2 pi divided by 4. And that means that c equals to the square root of 2 plus 3 root 2 pi all over 4. And that is the value of c. And finally, therefore my value, or the equation of the tangent, is simply minus the square root 2 of x plus the square root of 2 plus 3 root 2 pi divided by 4. It doesn't matter what curve you're dealing with, the steps will always be the same. I hope you enjoyed this video. If you'd like me to go through more tangent problems, please let me know, and don't forget to like and subscribe. Thank you.